Hello everyone. Welcome back to CS303 Operating System Concepts. In this session we are going to learn about CPU scheduling. Let's get started. Here is the outline that we are going to cover under this chapter. From this video, we are going to cover up to scheduling algorithm optimization criteria. From remaining videos, we are going to discuss how each scheduling algorithm works using some example problems. Before going to the content of this chapter, let's recap some basic concepts that we have already learned from previous chapters. Here, it will be useful to understand the difference between both single-processor systems and multiprocessor systems. If you don't remember what they are, please go through the previous materials and understand the concept behind them. What is CPU scheduling? CPU scheduling is a process which allows one process to use the CPU while the execution of another process is in waiting state due to unavailability of any resources like I/O, thereby making full use of CPU. CPU and I/O burst cycle. Process execution consists of a cycle of CPU execution and I/O wait. Process alternate between these two states. Process execution begins with a CPU burst. That is followed by an I/O burst, which is followed by another CPU burst, then another I/O burst, and so on. The final CPU burst ends with a system request to terminate execution. The durations of CPU burst have been measured extensively. Durations vary greatly from process to process and from computer to computer. The frequency curve is generally characterized as exponential or hyperexponential, with a large number of short CPU bursts, a small number of long CPU bursts. CPU scheduling deals with the problem of deciding which of the process in the ready queue is to be allocated the CPU. By switching the CPU among processes, the OS can make the computer more productive. In this case, we use scheduling algorithms. Different CPU scheduling algorithms have different properties, and the choice of a particular algorithm may favor one class of processes over another. Dispatcher. A module that gives control of the CPU to the process selected by the short-term scheduler. This function involves the following: switching context, switching to user mode, jumping to the proper location of the user program to restart that program. The dispatcher should be fast as possible, since it is invoked during every process switch. Dispatch latency. The time it takes for the dispatcher to stop one process and start another running. Optimization is a really important factor when it comes to algorithms. In order to check the performance of scheduling algorithms, we use 5 major criteria. Let's look at each of them briefly. CPU utilization keeps the CPU as busy as possible. Throughput is the number of processes that complete their execution per time unit. Turnaround time is the amount of time that needs to execute a particular process. Waiting time is the amount of time a process has been waiting in the ready queue. Finally, the response time is the amount of time which takes from when a request was submitted until the first response is produced, not output. In order to optimize scheduling algorithms, those discussed properties should be maintained as follows. Both CPU utilization and throughput should be maximized, and all the other properties, which are turnaround time, waiting time, and response time, should be minimized. In scheduling algorithms, we can identify 2 types of decision-making mechanisms. They are preemptive scheduling and non-preemptive scheduling. Preemptive scheduling allows a running process to be interrupted by a high-priority process, whereas in non-preemptive scheduling, any new process has to wait until the running process finishes its CPU cycle. There are various kinds of CPU scheduling algorithms in operating systems. In this course, we are going to discuss the following scheduling algorithms only. We will learn how each of them works from upcoming videos.